Achha. Good morning, all of you. Today we will start the bearing capacity of shallow foundation. After the earth pressure theories, this is new module where we are going to understand how can we calculate the bearing capacity for a shallow foundation, as well as how can we understand the various definitions which will come under the this bearing capacity of shallow foundation module. So this is the broad chapter, bearing capacity of shallow foundation. Under this broad chapter of bearing capacity of shallow foundation, first we will understand what are the bearing capacity, various bearing capacity, or what are the various definitions. So if we move forward, then we can see various definitions under this bearing capacity of shallow foundation. So what is the footing? First definition is footing. So a footing is a portion of the foundation of a structure that transmits load directly to the soil. Basically, this foundation is the soil structure, and this is related to the direct related to your composite structure or any solid structure. So any footing material we can use, or any construction component as a footing we can use. So footing also a part of the foundation, and we have required to find out the capacity of the footing and the load which can bear the soil. We have to calculate through this bearing capacity of shallow foundation. So in this footing, normally already you have studied in your third semester and fourth semester that what is footing. Footing, normally various type of footing we can construct during our construction, like your concrete footing, then your timber footing, your steel structure footing we can use in our construction site. Next is foundation. Foundation is the part of the structure which is in direct contact and transmit loads to the ground. Basically, this foundation directly transmits the superstructure loads to the ground. So basically, foundation, the part which can transmit the entire load to the soil or ground, below the ground. So the entire load, like suppose load of a building, load of a suppose any huge massive structure like gravity dam, or any structure, any concrete dam, or any other type of structural load can pass through this foundation. Also, you can write down these definitions for ease of your understanding. Next is bearing capacity. Now we have required to calculate bearing capacity, or to find out the bearing capacity of any footing as well as the foundation. So entire foundation, how much load can carry, this is our motive of this study. So as per definition, the supporting power of a soil or rock is referred to as its bearing capacity. The term bearing capacity is defined after attaching certain qualifying prefixes. So various bearing capacities we can see in this chapter, as well as we are going to study various bearing capacity under this chapter. And basically, the bearing capacity, the supporting capacity, the soil or our foundation, which are we are going to suppose we are going to construct any structure, which type of foundation we will choose, and what will be its bearing capacity, or the capacity, load carrying capacity, we will calculate through bearing capacity formula or the procedure. First definition under this bearing capacity is the gross pressure intensity. Please write down this definition. What is gross pressure intensity? Because to calculate the bearing capacity, we have required these parameters. Parameters in the sense bearing capacity parameters, or these various definitions or various parts of the bearing capacity we have required to calculate during bearing capacity calculation. So first definition is gross pressure intensity is defined by small q. So we can define this gross pressure intensity with small q. The definition is the gross pressure intensity q is the total pressure at the base of the footing due to the weight of the superstructure, self weight of the footing and the weight of the earth field. So before this gross pressure intensity, you should have clear idea that what is the actual total foundation. Okay, actually total foundation is the combination of footing and your excavated part where you are going to construct or as well as you are fix your footing and the superimposed loads due to the soil. After installation of your footing, you will fill the vacuum space with soil, and this load will also come under this gross pressure intensity. So the gross pressure intensity Q is the total pressure at the base. Obviously it will act at the base of the footing due to the weight of the superstructure, the entire load of the structure, self weight of the footing and the weight of the earth field. Now this superstructure is totally will come under your RCC and structural analysis part. Footing also you will design in your RCC and you can analyze this footing part in your structural analysis subject, and the weight of the earth field will be calculated by yourself. Now weight of the earth field, I think you have some idea how can we calculate this weight of the earth field. We can calculate the weight of the earth field, or to calculate this weight of the earth field we have required the unit weight of the soil and the depth of the soil, the depth where we are going to fill the earth or excavated depth for the foundation. After construction or installation of the footing, we are put the soil materials over the your footing structure to fill up the gap. So the entire load of the earth or the soil mass will come under this gross pressure intensity. So I think gross pressure intensity is clear. If this gross pressure intensity small q is clear to you, next is net pressure intensity. So basically our foundation should be like that to capable to take this gross pressure intensity, because the entire load to be carried by this foundation, and we are going to calculate the bearing capacity of this foundation. Now after this gross pressure intensity, under this gross pressure intensity, some specific terms or some specific definitions are involved, like net pressure intensity. So net pressure intensity can be defined by Q suffix n, small q suffix small n. So it is defined as the excess pressure or difference in intensities of the gross pressure after the construction of the structure and the original overburden pressure. Thus, if D is the depth of footing. So basically, when we have required to find out the pressure which is come from the your structural part. Okay, when we are not going to consider the soil part or soil material as a load on the footing or excess pressure due to soil or filler material, then only the footing load will be considered for your net pressure intensity. So as per definition, it is clear that it is defined as the excess pressure or difference in intensities of the gross pressure after the construction of the structure and the original overburden pressure. So excess material which we are used to fill the excavated part of the foundation, that is called the overburden pressure, or the pressure which is come from the excess soil is called overburden pressure. So overburden pressure basically nothing but the excess soil or the filler soil which are basically used to fill the vacuum space or the gap or to protect the footing in its place properly, we are used the excess soil or the vacuums to fill the vacuum space, and the pressure generated from that type of soil is called overburden pressure. So overburden pressure, if we deduct this overburden pressure from the gross pressure intensity, easily we can calculate the net pressure intensity, that is defined by Qn. So during calculation of the bearing capacity, you may be asked in your question, that is not only gross pressure intensity, net pressure intensity. Calculate the net pressure intensity. So to calculate the net pressure intensity, you should have the all this data. Which is the data? Data means your dimension, proper dimension of the foundation. Now the weight of the footing and the weight of the soil which are used for the filling. So the equation is, you can see here. Please write down this equation Qn, because this equation is required to calculate the net pressure intensity. Qn equals to Q, that is small q, minus sigma dash. Sigma dash is the overburden pressure. Okay, overburden pressure. Sigma dash is the overburden pressure, and this sigma dash we can calculate from the unit weight and the depth of the soil, that is gamma d. So if you have the gamma value and the depth of the footing, or the depth of the foundation, easily you can find out this excess overburden pressure. Okay, excess overburden pressure. So Q minus, basically the formula is Q minus gamma d, where gamma is the average unit weight of the soil above the foundation base. Okay, so I think foundation, from the definition, foundation is clear, footing is clear. Footing is totally structural part. In RCC you already studied what is footing, type of footing. Any kind of footing we can use for our superstructure, and various type of shapes are involved in this footing, and entire part of foundation involved footing, overburden pressure, size of the foundation, unit weight, all those things are required to calculate the bearing capacity of shallow foundation. The next part of this shallow foundation, or next definition, we can say the ultimate bearing capacity, defined by Q small a. Please write ultimate bearing capacity. After calculation of net bearing capacity, net pressure intensity, or net pressure intensity, we are required to find out the ultimate bearing capacity, QF. As per definition, the ultimate bearing capacity is defined as the minimum gross pressure intensity at the base of the foundation at which the soil fails in shear. So most of the cases we have required to find out this ultimate bearing capacity, because ultimate bearing capacity is the pressure where soil can fail. Okay, this pressure is required because failure, we should know which load, at which load soil can failure in shear. Okay, so ultimate bearing capacity is defined the minimum gross pressure intensity at the base of the foundation at which the soil fails in shear. This is the most of the important bearing capacity definition, because ultimate bearing capacity is required, we can put with this factor of safety this ultimate bearing capacity, because ultimate bearing we cannot reach the load, or we cannot put the load, entire load of the superstructure up to the ultimate bearing capacity. We should maintain with some factor of safety value. There is net ultimate bearing capacity, QNF, net ultimate bearing capacity. The net ultimate bearing capacity is the minimum net pressure intensity causing shear failure of soil. The ultimate bearing capacity QF and the net ultimate capacity are evidently connected by the following relation. So basically this net ultimate bearing capacity is defined by Q A net, and This is nothing but QNF can be defined QF minus the excess overburden pressure. So QF is ultimate bearing capacity. If we deduct the excess pressure or excess overburden pressure from this ultimate bearing capacity, we will get this net ultimate bearing capacity. So these definitions are very important. Please keep it in your mind, because during calculation, numerical calculation, you may be asked any one of them. Suppose what is the gross pressure intensity, what is net pressure intensity, what is ultimate bearing capacity, what is net ultimate bearing capacity. Only clear idea, only if you have clear idea, then you can answer this type of questions. Okay. Obviously, where sigma dash is the effective surcharge at the base level of the foundation. Dash already I have said that this sigma dash means the effective case when we are considered only the stress or the load from the soil mass, no water or the pore water pressure, or suppose no neutral pressure is considered, then this dash we are used, or simply this is the effective stress we are considered in this case. Next, net shape bearing capacity. Net shape bearing capacity, that is QNS. You should keep in your mind this terminology, this type with terminology and nomenclature also. This QA, QNM, QNS. Okay, this nomenclature also important, because during writing your formula, you should use these nomenclatures. Okay, QNS, QNL, QM. Without nomenclature is very difficult, because the maximum time will take during exam. So using this nomenclature you can also define, because these are all worldwide valid and these definitions are worldwide same. Okay, this net shape bearing capacity and net ultimate bearing capacity. So you should use these nomenclatures. Okay. For net shape bearing capacity, this is QNS. QNS nothing but net shape bearing capacity is the net ultimate bearing capacity divided by a factor of safety. So already just I have said factor of safety. About factor of safety. Factor of safety, one of the most important part of this formula, also as well as for this bearing capacity of shallow foundation, because without factor of safety we cannot go. After calculation of the gross pressure intensity, net pressure intensity, ultimate bearing capacity, net ultimate bearing capacity, finally we have required some factor of safety which we can apply in our formula, basically to calculate the actual load which we can put or which we can allow for our foundation. Okay, so this is only possible when you have the QNF value. QNF means your net ultimate bearing capacity. When you have the net ultimate bearing capacity. So although this sigma dash, this is effective overburden pressure, is basically not required for your net pressure intensity case, even your net ultimate bearing capacity case, as well as in your net shape bearing capacity case. So these excess overburden pressure is all time is excluded from those equations. So ultimately the net shape bearing capacity can be calculated QNS equals to QNF divided by factor of safety. F is the factor of safety. So which factor of safety will be considered? In this case, normally we are considered 3 to 4. 3 to 4 value for to calculate the net shape bearing capacity. We are considered the 3 to 4 factor of safety. Factor of safety value 3 to 4. So this is our ultimately our intention to find out the bearing capacity of the soil. Net shape bearing capacity is our final intention, because without excess pressure, how much load we are allowed to carry. Okay, this is our final intention. And finally, the shape bearing capacity. Shape bearing capacity is maximum pressure which the soil can carry safely without risk of shear failure, is called the shape bearing capacity. maximum pressure which the soil can carry safely without risk of shear failure is called the safe bearing capacity. This is the safe bearing capacity, but net safe bearing capacity is one of the important factor for our